Ethernet is the most widely used technology for building local area networks, or LANs. It allows devices like computers, printers, and servers to communicate within a limited area. Think of it as the nervous system of your home or office network. Without Ethernet, sharing files and accessing the internet would be much more difficult. Ethernet sets the rules for how data conversations happen. It ensures data reaches the right destination without interference. This is crucial for the internet, online gaming, and streaming videos. Ethernet is popular because it is inexpensive, easy to install, and offers fast speeds. From small home networks to large data centers, Ethernet connects our digital world. Over the years, Ethernet has evolved to meet the demands for faster and more reliable networking. Yet, its core principles remain the same, showcasing its robust and adaptable design. In the following sections, we'll delve deeper into the workings of Ethernet and its impact on modern computing. To understand Ethernet, we need to understand two key ideas: packets and frames. When you send data over an Ethernet network, it's broken down into small chunks called packets. Each packet is like an envelope with a destination address and the data itself. These packets are then encapsulated within Ethernet frames, which act like shipping containers for data. An Ethernet frame contains the source and destination MAC addresses, the data payload, and error-checking information. The MAC address, or Media Access Control Address, is a unique identifier assigned to every network interface card, or NIC. Ethernet uses a clever method called carrier sense, multiple access with collision detection, or CSMA-CD, to manage data transmission. Before sending data, a device listens to the network to see if it's idle. If the network is clear, the device transmits its frame. However, if two devices try to transmit simultaneously, a collision occurs. When a collision is detected, both devices stop transmitting and send out a jamming signal. This signal alerts other devices on the network about the collision. After a random back-off time, the devices try to resend their data, hoping for a collision-free transmission. Ethernet has come a long way since its invention in the 1970s by Robert Metcalfe and Xerox PARC. The earliest versions of Ethernet used coaxial cables and transmitted data at speeds of 2.94 megabits per second. These early networks, while revolutionary at the time, were relatively slow by today's standards. With the advent of new technologies, Ethernet evolved to use twisted pair cabling, which is cheaper and easier to install than coaxial cable. This paved the way for the development of faster Ethernet standards such as 10 megabits per second Ethernet, or 10 base T. The T in 10 base T stands for twisted pair, highlighting this significant shift. As technology progressed, faster standards emerged, including fast Ethernet at 100 megabits per second and Gigabit Ethernet at 1000 megabits per second, or 1 gigabit per second. These advancements dramatically increased data transfer speeds, making it possible to share larger files, stream high-definition videos, and support more devices on a single network. Today, Ethernet continues to evolve, with standards like 10 gigabit Ethernet and even faster technologies becoming increasingly common. The development of faster Ethernet standards ensures that our networks can keep up with the ever-growing demands of data-intensive applications. Section 4. Cables and connectors. Choosing the right Ethernet for the job. Ethernet cables, easily recognizable by their RJ45 connectors, come in different categories. The most common types are Cat5e and Cat6. Cat5e cables support speeds up to 1 gigabit Ethernet, suitable for most home networks. Cat6 cables offer higher bandwidth, supporting 10 gigabit Ethernet over shorter distances. Ideal for high-performance applications like servers and 4K video streaming. Choose based on your network's needs. For most home users, Cat5e is sufficient. For faster speeds or business networks, opt for Cat6. Consider cable length. Signal degrades over longer distances. For runs over 100 meters, use switches or repeaters. Section 5. Conclusion: the enduring legacy of Ethernet. Ethernet has become the dominant networking technology for LANs due to its simplicity, reliability, and affordability. Its ability to adapt and evolve over the years, constantly increasing in speed and efficiency, has cemented its place in the world of computing. From the early days of coaxial cable to the high-speed connections we enjoy today, Ethernet has revolutionized the way we communicate and share information. Whether it's connecting devices in our homes, powering business networks, or forming the backbone of the internet, Ethernet plays a vital role in our interconnected world. As technology continues to advance, we can expect Ethernet to keep pace, ensuring that our networks remain fast, efficient, and capable of handling the ever-increasing demands of the digital age. Understanding the basics of Ethernet empowers us to make informed decisions about our network infrastructure and appreciate the ingenuity behind this ubiquitous technology.